Hello all. In the last video, we were discussing about the theory of logistic regression. Let us now discuss about the practical approach of logistic regression. How to write algorithm in Python. Let us now proceed with that. The step number one in any of the machine learning algorithm is to understand the problem statement. So here we have taken the Titanic data set. Hope all of you might have seen the Titanic movie, right? So we have a data set here. We need to find out whether the passenger is survived or not, right? So this is the problem statement here. And here, what is the dependent variable? The dependent variable is about the survival, whether the passenger is survived or not. So this is basically categorical. If the dependent variable is categorical, then we call it as a classification, right? So the second step analytic approach, we decide that it is a classification algorithm because the dependent variable is categorical. Now the third step is like data requirement and data collection. We are not bothering about data requirement and data collection. The reason is here we have already collected the data, so we are not going to do anything with this. But when you are working with any new project in your organization, you have to sit with your team, discuss with them to know about the required data, and the same has to be collected. So for now, we are not going to bother about data requirement and data collection. The next step is data understanding. So what is data understanding? So here, let us try to understand about the data set. Okay. So for that, what I'm doing now, let me show you how the data set is looking like. We will also try to understand about each and every attribute now, right? So the first one is passenger ID, which is nothing but the ID of the passenger, which is not really helpful to me. So what I will decide, it is not really required. The second one is survived. So where the people would be making mistake is that we are trying to figure out the survived, right? Survived is the dependent variable. If you look at this, it is looking like a number, right? 0 and 1. So people identify that survived is a dependent variable, but the major mistake what they do is just because it looks like a number, they assume that it is a regression problem. Again, try to understand the meaning of it. So 0 means not survived, 1 means survived. Then the third one is like a P class. P class is again 1, 2, 3. So what does this 1, 2, 3 stand for? First class, second class, and third class. Again, this is the categorical data. Then the next one is like a name, right? The name of the passenger. And here we can drop this name column because based upon the name, definitely we can't say that whether the passenger is survived or not, right? Based upon the name, we cannot say that whether the passenger is survived or not because like we are not going to no, make the people to sit according to alphabetical order, right? So that is not possible over here, right? So in such case, definitely name is not really required because the name, based upon the name, the person is not going to survive. The next one is about sex. Sex again like a gender, so it is basically like a categorical, male or female, right? Male or female. And now people will think that in the previous one I said name is not required. Based upon the name, we don't say whether the person is survived or not. Immediately people assume that sex is also not required. It's not like that because we really do not know how the men are asked to seated or how the female were asked to seated. The seating arrangement could be depending upon the sex. So when we are not clear with that, we are not supposed to drop that particular column, right? The next one is like age. Age is a number, right? Age is numerical. Again, we don't know. Maybe the young people may be at, I mean, like the senior people may be at one place, so we have no clarity about it. So we are going to consider this. Next one is SIB, sibling, spouse. It is numerical, right? Whether the passenger is traveling alone or either he is traveling with a sibling or spouse. The next one is PARCH, parent child. Whether the passenger is traveling alone or he is traveling with his parent or child. Then ticket number, if you see that the ticket number is like this, right? So definitely this is not going to be helpful to us. So we can actually drop it. And then fare. Fare in the sense like it is the amount, right? You can see that what I have decided is I'm not going to use the fare. Why I'm not going to use it? Because I think like that is already included in this passenger class. So I can take a call whether to use this fare or not. Right? So I have decided like it's not really required. The next one is cabin. So cabin number may be looking like it is important because which cabin cost more danger, we really do not know. But there is a challenge if you see when I look at the data set, I can see like there are a lot of missing values in cabin. So we need to look into this. The last one is embarked. Embarked is nothing but the like where in which port the passenger has boarded, right? Again, this is categorical. So what I need to remember is passenger ID I can drop, name I can drop, and I can drop ticket, fare, cabin. I need to think about it. Embarked and sex are categorical. So definitely I need to do the encoding. Let us now start with the algorithm. Step number one, we need to import the packages. So I have imported NumPy, Pandas, Matplotlib, Seaborn, and then I'm using logistic regression algorithm. So I'm writing like from sklearn.linear underscore model import logistic regression. And then we need to split the data into train and test. Do you remember? In all the machine learning algorithms, we are supposed to split the data into train data and test data. And then these two codes too, I mean, like when you run the code of logistic regression, there is a chance that we would be getting the warnings there. So to avoid the warnings, we are writing like import warnings, warnings dot filter warnings ignore, right? So step number one, I have imported all the packages. Then I want to load the data set. So this is the data set name. So how I'm writing, if you see that, you can write TIT. If you press tab, you will be getting the name. Because most of the times what we will do, we will write the name of the file wrongly so that the algorithm may not work, right? So it is always better to write the first two letters or three letters and then you can press tab, right? And then df.sample. You can see that this is how the data set is looking like. You can see that, right? So always it is better to write df.sample, okay? So that randomly it would be displaying the uh, data, right? So we will get more clarity. You can see that in the cabin column, there are a lot of nans, right? There are a lot of missing values over here, right? Perfect. Likewise, in age column also you can see NaN, which means that it is giving an idea that there are missing values in age column also, right? Then let me run this code df.shape, 891 rows and 12 columns, right? 891 rows and 12 columns. So then let me write df.dtypes. You can see the data types of all the attributes. Okay, I told you, right? Survived is basically categorical. But just because it is represented as number or I mean, like when you write the code, it will display it as integer only. So we as a human being, we should only figure it out whether it is categorical or numerical. Then df.info. So the number of rows should be 891. But if you see here, it is lesser than 891, which means that there are missing values in the age column, there are missing values in the cabin column, there are missing values also in a marked column, right? And also you can see the data type here. Now I want to know how many missing values are there. So what is the code to get the number of missing values? df.isNull.sum. So you can see 177 missing values in age, 687 missing values in cabin, and 2 missing values in embarked, right? So here the number of missing values are more. So can we treat it if you ask me? Definitely it is going to be tougher. So we are not supposed to consider this cabin column. So we can drop this attribute. Okay. For age, there is a chance you can replace the missing values with a mean or median. And here embarked, you can replace it with a mode. Right. So that is the idea. So now we need to do the data preparation step, right? If you see that, once we have done it, we need to do the data understanding step, right? So that's what we are doing right now. So first I'm doing count plot. X-axis is equal to survived, data is equal to DF. So you can see that 0 is not survived. So not survived count is more than survived. But can you see the number clearly? It is not very clear, but generally visualization would be impressive to the people, right? So it is very important to the visualization. So now in case if I want to see exactly the count, you can write like dot value underscore counts. So you can see like a 0 class dot survived 549, survived there is 342, right? Survived 342. Likewise, what I'm doing, x-axis is equal to survived and hue is equal to 6. Okay, so what I want to do here, I want to find out according to the 6 how many people survived. So basically, I want to study about 2 categorical attributes. There, the count plot helps us a lot. So when I run it, you can see that in survived, female count is more than male. So how do I get to know the numbers? PD dot cross tab, survived and sex. You can see like a male not survived is more. You can see that, right? And female survived is actually more. Do you get that? So cross tab is actually used when there are 2 categorical attributes. Count plot can be used for 2 categorical or 1 categorical. If you want it in the visual format, you need to go for count plot. If you want to get it as a table, then you need to go ahead with the cross tab. Right? So now, likewise, you can also compare survived and P class. So when you do that, you can see that the passenger class 3 not survived is actually more, right? But here, if you see that it is little equally the same, there is small difference, right? Class 1 and 3, there is a small difference, right? So I have written cross tab here, survived and a class. So if you take this not survived, passenger class 3 is more. For survived, 136 for passenger class 1, 119 for passenger class 3, right? Now, in case if I want to study about like which age group were traveling, which passenger class, one categorical and one numerical, we can go ahead with the box plot, right? So SNS.box plot, I have given like a P class and age. Always remember, whenever you use box plot, there should be one categorical, one numerical. It will give you a very good inference. I could see that passenger class 1 is widely used by the people of all age groups. There are no outliers also. But if you take this here, there are outliers, very less number of kids were using passenger class 2, right? And here, if you see, there are very less number of senior people were using it, right? Likewise, if you see that this is the age group remaining or outliers here, right? Now I have decided to drop the cabin column. Why? Because the number of missing values are more in cabin column. So I'm just dropping it. Let me run the code now. You can see that yes, it is being dropped. Now here, what is the mistake being done by the people? So you need to always write df equal to df dot drop. That is data frame equal to data frame dot drop. I have named it as df. You can give any name. You should write the same names here. Or else what I can write df dot draw. And here you can write comma in place equal to true. Right? So both would be working. Either you should write in place equal to true. Don't write both, right? Either you need to write in place equal to true, or else you need to write df equal to df dot drop. Okay. So once you do that, the cabin column would be dropped. You may be thinking, what is this axis equal to 1? Axis equal to 1 represents column. Right? So I'm going to drop the column. Don't assume that column number. Axis equal to 1 represents column. Axis equal to 0 represents row. Right? So that's the difference. Then we are trying to drop the null values, right? So df equal to df dot drop NA. So what are we trying to do now? We are trying to drop the missing values. Okay, so the first approach, what I'm doing, I'm just going to drop the missing values. Then I want to know the score of my model, right? So I'm writing df dot drop NA. After that, if I see that there are 712 rows, and 11 columns in my data set. Okay. Now df dot head. You can see that this is how my data set is looking like. Before that, we could see NAN, right? Now you are not able to see any NAN because I have dropped the missing values. Now I need to encode all the categorical attributes. What are the categorical attributes? I have sex column, I have embarked column, I have passenger class. Okay. So df equal to pd dot get underscore dummies. So what type of encoding I'm using here is one hot encoding. One hot encoding. So the column names also I have mentioned here and data is equal to df, right? So once I run the code, you will be understanding what is happening here. In sex column, you can see male as well as female. Likewise, here what is happening? Sex underscore female, sex underscore male, right? The first data is male, so male would be 1, female would be 0. The second one is female, so female would be 1, male would be 0, and so on, right? So likewise, it would be doing for embarked class, you can see, it would be also doing for the passenger class also, 1, 2, 3. So the first data should be passenger class 1, the first one should be passenger class 3, the second one would be passenger class 1. Can you see that? Yes. Now I'm dropping all the unwanted columns that we have discussed before. Passenger ID, name, ticket, and fare. Axis equal to 1 represents column. Okay. So I have dropped all the columns. Now if you see that everything is looking like a number. But for the safer side, once again you write df dot dtext. So now you can see that everything is integer and u integer. Ignore this d type equal to object. This is actually for this one. So don't worry about it. So here, if you see, everything is integer, float, and also uint, right? So now in x-axis, I have taken the column other than survived, all the attributes I'm taking in the x-axis. In y-axis, I have taken the survived attribute. In y-axis, I have taken survived. In x-axis, other than survived, we have taken all the columns, right? So once we do that, we need to split the data into training data and test data. So x underscore train, x underscore test. Remember, you have to write it this order only. First you write for X, then you write for Y. If you give capital X, capital Y, here also you have to give capital X, capital Y. If you give capital X, small y, here also you have to give capital X, small y, right? So trade test split, what is this trade test split if you remember? Trade test split, right? So we have already imported it. That is the same I have written here. And then I am passing this X and Y here. Test size is 0.30, which means test size, I'm giving like 30%, train size is 70%, and random state is equal to 1. So what is this used for? This is just to freeze the score. Okay, if I'm writing random state 1, every time when I run the code, it will be using the subset of training set and test set the same. So how can I explain this? Say for example, I have 10 observations. Okay, so let me make it clear. Most of the times people get confused with this. Sorry, 6, 7, 8, 9, 10. Okay. Say for example, 30% for test. Okay. For example, when I write random underscore state equal to 1, just assume that 4, 7 assumption only, right? Say 4, 7, 10 is for test data. Remaining all would be for the training data. Whoever is writing random state equal to 1 now, everybody would be getting the same data for testing and the remaining data for training. If somebody is writing like random underscore state equal to 100, they would be getting different test data, right? But we never use it in the industry. It is just for the classroom because so that everyone get the same score, right? Even you can run again and see the score would be changing when you remove this random state. Okay. So now I'm instantiating my model like a logistic regression, and then we need to fit it with the train data, right? Fit with the train data, and let us get the score of the train data, score of the test data. You can see that the difference is 2% only, 80% and 78%. The score is really looking good, right? So we actually get here a good score, a pretty decent score. But should we try to improve the score? If you ask me, yes, we have to try to improve the score. Okay. What is the approach we have done? We have dropped the missing values. So what you can do, if you want, you can try with replacing the missing values with a mean, right? And replacing the missing numerical values with a mean or median, and we try to replace the categorical missing values with a mode, right? So try to do that. Let me know the score. So how you need to practice from the beginning, you have to write the code. You can pause the video, write the score. I will also give the link of this data set in the description. Take the link from there, write the code, work on it, replace with the mean that we have discussed in the EDA session. So replace it with the mean or median, replace embarked with the mode, get the score, and you need to tell me the score also, right? So now let us continue with this. Along with me, you should write the code. Okay, you can pause the video in mid. You have to write the code. Write the code. That is very important. If you look into this one, you feel like you understood everything, but later definitely you won't be able to do it. Okay. So now I want to predict for the test data. Now we will just look into the metrics of the logistic regression, or I can say metrics for the classification model, right? So from sklearn, I have imported metrics. I want to go ahead with the accuracy score. Okay. So let me run this now. You can see the score now. Let's see. So the score is 78. So how do we get the 78? If you remember this score, 7803, right? The same number we are getting. So now, confusion matrix, do you remember? Like we have discussed in the previous video, the theory video, we have discussed about the confusion matrix. So matrix dot confusion underscore matrix. What is this y test actual value of y? What is this predictions predicted value of y? In the example we have taken, we had the images of the cat, right? That is test value of y and the predicted value of y labels equal to 1, 0. And just we are using the data frame here and the heat map. You can change the figure size of the heat map and then whatever name you have given here, that you need to pass it here and annotation equal to true. What does that mean? I want to get the data inside. If you can try with this, right? You can remove this and see like there won't be any values, but you can find the values only from the color bar. And then FMT equal to G. That is basically scientific notation, right? Otherwise, if you do not write this, you will be getting like 1E2, right? So in case if you want to avoid that, you can write FMT equal to G. So what is the takeaway now? Let me take the pen. You can see this. This is basically predicted one. No, predicted one means what? Positive. Actually, also it is one, which means what? True positive. If you take this one, predicted 0 means negative, actually also 0, true negative. If you take this one, predicted is 0 means predicted is negative, actual is 1, which means false negative. Predicted is 1, right? So positive, actual is 0. So which means what? False positive. So we have already discussed about accuracy, right? So let me tell you some other important metrics now. Accuracy, we have seen like 0.78 something, right? So how we are getting it? So first let us add this 165 plus 23 plus 24 plus 102. What do we get? Take the calculator and check it up. We are getting like 240. Okay. So what is the total number of data we are actually working on? 712, right? We had 891, but after that we dropped it, right? So what is the number we have here? 712. So let me write down. So 712, correct? So in 712 data, we have taken only 30% of the data for the test data, right? So what is the 30% of 712? You will be getting it like 240, yes? So only for the which data? Only for the test data we are actually working on, right? So let us now calculate accuracy. True positive plus true negative divided by true positive plus true negative plus false positive plus false negative, right? So, right. So if we calculate it, let's see now step by step, we will try to solve it. This we have discussed like true positive. This is true negative, right? This is false negative. This is false positive, right? So let us now calculate the accuracy. Total was like 240, no? Right? And a true positive plus true negative, right? What is true positive? 65 plus true negative is 102. So 167 divided by 214. What do we get? 0.78037. This is what we got it like accuracy already, right? So that part is clear. Let's now go ahead with the recall. What is meant by recall? Recall is out of actual positives, how many are true? So true positive divided by actual positive. So which is true positive divided by actual positive means what? Actual positive is basically, if you look at this one, this is for predicted column, right? This column is predicted, right? So this is for row. So what do we get for actual positive? Actual is this side, rows, right? So actual positive means actual 1, right? So TP plus FN, correct? So what is true positive? True positive, you can see that 65 divided by 65 plus 23. If you calculate it, you would be getting the recall. The next one is like a precision. What is meant by precision? Out of predicted positives, how many are true? So TP divided by predicted positives. In predicted positive means this. So TP plus FP. So if you substitute 65 divided by 65 plus 24 would be precision, right? So this is how the metrics would be calculated. And finally, F1 score. What is meant by F1 score? 2 into precision into recall divided by precision plus recall, right? So if you calculate it, you would be getting F1 score. But in the industry, most probably, we will go ahead with the confusion matrix, right? So let me repeat it. When you watch this video, you need to write the code simultaneously. I would be giving the link in the description. And the next point is that I have just tried with dropping the missing values. You need to replace the missing values of age with the mean and embarked with the mode, build another model, get the score, and replace the missing values of age with the median and embarked with the mode and get the score. Compare all the three approaches and let me know which approach is giving a good score. So hope all of you understood it. Thank you.